Have you ever had the experience of being splashed with dirty water on your clothes when walking on the street by a speeding car? You might have also noticed the higher the speed of the car, the more distance the splashed water will move. What is happening? The higher the speed of the car, the more is its kinetic energy which will be imparted to the splashing water. That is why it can go farther into your dress. Makes sense? In classical physics, the emphasis is on the mass and the velocity. However, in quantum mechanics, which is more probabilistic in nature, we focus on the energy and momentum. As such, photons should have a zero momentum because photons have no mass. But with the simple calculations, we can recognize the momentum of a photon is h divided by lambda. H is the Planck's constant, lambda is the wavelength. Now remember, metals have ionic bonds. That means the outer shell of electrons are freely roaming. They can be pushed out. If you throw a pebble to that puddle of electrons, some will splash out, of course, depending on the energy of the pebble. Here, instead of a pebble, we use a photon, and the energy of the photon depends on its frequency. Higher frequency, lesser wavelength means higher energy. Einstein did not like the idea of quantum mechanics. He wanted to disprove it. That is why he did the photoelectric experiment. However, his inability to disprove the photoelectric concept of quantum mechanics, that is what made him the recipient of Physics Nobel Prize in 1921. What did he do? He took different metals and he applied different wavelengths of light or different frequencies into that metal. And as he increased the frequency of the light, some electrons started jumping out. Here at a very low, this is the energy, this is the frequency. At a very low frequency, no electron will come out. As he increased the frequency, you can see electron starting coming out. Different metals have different work functions. That is this point, okay? And only at that work function, till that time, no electron will come out. That minimal threshold of energy from the frequency is called work function. The leftover energy is imparted to the electron as its kinetic energy, which can be measured. Element number 1 will have a work function here, and the electron will come this way with higher kinetic energy. Another metal may have a different work function, but once it is released from the metal surface, it will also fly off, leaving the metal positively charged. All the electrons coming out, their kinetic energies, they are parallel to each other, means they have the same slope. You know what that slope was? That was 6.626 multiplied by 10 to the power of minus 34 joule second. Remember, that is h, the Planck's constant.